Thank you. Good morning, everybody. Great pleasure to be back here with you in Berlin today. What I wanted to do is share with you some of the work we're doing both at Senseable City Lab, research group at MIT in Boston, and also MIT has a new research unit in Singapore, and also at our design office, Carlo Ratti Associati. I just want to start with a little video. So the reason I show you this is that it actually tells you something about an endeavor we've been trying to follow for many, many years. It's about, how we can create an environment around ourselves in architecture. Oops. Oops, sorry. Don't know what happened there? So, just 1 second. Should be done. Yeah, we're fine. Sorry about that. So how can we create a space around ourselves that responds to us in a dynamic way? When Michelangelo sculpted the Moses, here you see the statue, when he sculpted it, so the story goes. He took a hammer, he threw the hammer at the Moses, and he shouted, "Perché non parli? Why don't you speak?" So how can we create something that speaks back to us in architecture, in sculpture? That's what we've seen over and over. We've seen it in Baroque architecture, these beautiful buildings trying to capture movement. We've seen it in Art Deco and Art Nouveau. We see it always today. This is one recent building that tries to be like fluid. It's a bridge in Spain that tries, again, to capture movement in a different way. Now, if you look at this, however, there's kind of a little bit of a tragedy in it. The tragedy is that it tries to capture movement, but it's frozen. It's dead. It's made of concrete and steel. It doesn't really respond to us in a dynamic way. And actually, there's another line of research that we've seen over and over in architecture that try to have things interacting with us in a different way. And then goes back to, for instance, Cedric Price. Here you see his Fun Palace that was proposed in the second half of the past century in London. Cedric Price was really inspired by cybernetics, the idea that we could have a different type of interaction between us as humans and architecture and the environment around ourselves. Well, a lot of what Cedric Price was talking about and the people at the time were trying to experiment is now becoming possible. And it's becoming possible because our cities are being covered, layered with many different types of digital information, with sensors, with networks. It's almost like the digital and the physical, or if you want, bits and atoms converging in physical space and creating incredible new potential for architecture. If you look at this space from one side, you can just call it Internet of Things or Internet of Everything. If you look at it from the other side, it's about architecture almost becoming alive, as I showed you in the initial slide, in the little movie at the beginning. A lot of what is happening in a certain sense is that in this cybernetic relationship, we can collect a lot of information from the space around ourselves, we can sense it, and then we can respond to that. We can actuate. And sensing and actuating is really the basic of what we do as dynamic systems, as living systems. When we see each other, we sense each other, we collect information from each other, and then we respond to that information, so sensing and actuating. And what's happening today is that almost every atom out there, or the physical world, is becoming both a sensor and an actuator. Today we can understand the city like this. This is actually a beautiful visualization by Pedro Cruz, who was for a while at our lab at MIT, looking at the city of Lisbon and using billions and billions of data points collected from the taxi network, from GPSs, in order to see movement and flows in the city. And again, we couldn't understand the city like this just a few years ago, but we can do it today. In the next slide, I'll show you something that is one of the first projects we ever did. But I thought I'd show it today because, well, Germany is somehow involved in it, and also, we're in the middle of the soccer Europeans Cup now, Champions Cup. So what I'll show you is what we did for one of the first projects of the lab back in 2006, and it was the first time we looked at anonymized data from the cell phone network in a big city. The city was Rome, and in order to understand what goes on. And in this case, it was 2006. It was when in Germany, the Soccer World Cup was happening. Italy and France were playing back in 2006. And look at what happened in the city of Rome by looking at anonymized and aggregated data from millions of cell phones. So what you see here is the day of the final, the day of the World Cup final. Before the match, people moving here and there in the city. You see the river, you see the Colosseum in the middle. It's the early afternoon, then the match begins, silence. Nobody talks anymore. France scores, Italy scores. Half-time, people make a quick call. Then second half, end of normal time, first overtime, second, Zidane, the famous headbutt, and finally, Italy wins. That night, everybody went to celebrate in the center, and you see a big peak over there. And then the following morning again, everybody went to meet the winning team and the prime minister in the center. And by the end of the day, actually, people went to celebrate at a place called Circo Massimo, where since Roman times, people go and have big parties. And you see a peak at the, in the lower part of the image, which is everybody moving there. So we can look at this. We can look at this at the scale of the city. So what happens in our cities with analyzing data from networks. But we can also look at things at the global scale. And what you have here is actually how New York connects with all of the planet. Is data from the AT&T network, is both internet and cell phone and landline, and how the city connects with all the others. And how actually this information changes. It changes over time with the day starting and ending. And it changes over space. So how the two become the two determinants of this network of flows that embraces our planet. Now, what you see here is you see the overall view. You see the daytime and the nighttime as they move. And we'll zoom in into a moment. You see how, in this case, London starts to connect with New York, London waking up, all of Europe waking up, and the main hubs in Europe exchanging information. You go see South America here. You can see Buenos Aires and the main Brazilian cities, Rio, Sao Paulo. That's Asia going to sleep. So you see the amount of information reducing. The night is coming all over Asia. Africa, quite sad. Actually, out of the top 300 cities, we only have a couple of them. We got Joburg and Cape Town. And then some of the main Australian cities, again, connecting on this and being part of this global network. So we can actually look at this at the scale of the city. We can look at it at the global scale. We can look at this also at the scale of the object. In this project, we looked at this computer. Today, we know everything about this computer. Every chip in it, you see it on the map over there. Every chip, we know where it was produced, how it moved on the planet, how it became this machine. However, a few years from now, you stop using it. After a few years, then it's being thrown away, and then you know very little about it. Today, we know everything about where things come from, but we don't know where they go. Sometimes this is what happened. A lot of electronics from Europe shipped illegally to Africa, from the United States to Asia. So our idea was, what if we could develop a little tag that we could put on trash and then start following trash? It's a little bit like when you go to hospital, they put a tracer in your blood, and they follow it through your body to understand what works, what doesn't work. How could we do this at the scale of an entire city? So we had to design the tag. We did it with Qualcomm, a big chip manufacturer in the United States. It's almost like a miniature cell phone. It gets location and then reports back location. I'll show you the first deployment we did. We're still working on the project. Actually, we are doing some international tracking, really for looking at smuggling waste, e-waste smuggling that's happening today. But I'll show you the first experiment that we did in the city of Seattle. We had 500 volunteers, came with 3,000 different pieces of trash, We put a little tag on all of them. And after putting a tag on all of them, we started following them. Here you see the 3,000 objects. The day of deployment in Seattle. After a few days, you see some of the main landfills next to the city. But then a big surprise, how far things started to travel. Sometimes in crazy way. Look at the trace that went to Chicago and then down to California. And still moving after 1 month and 2 months. We thought the Firewall Symphony was the right music. So what can you do with this? So if you are an engineer, if you are an architect, you can actually look at all the traces and try to think about how you can optimize the system. There's a lot of wasted energy into the system. Sometimes we actually put more energy into some objects than what we will ever recover from them by recycling them, reprocessing them, and so on. So the first thing is actually how we can use all this information in order to create a more optimized and streamlined waste removal system. The second thing that's very important is that this is part of what, you're very familiar with the notion of big data, is this incredible amount of information we can collect today from our cities and from our environment. And when you got big data and you share it with people, then you generate very interesting behavioral change dynamics. Let me give you an example. At the end of the project, we were sharing all the information about the objects, about the trash, with the volunteers. And some of them came to us and said, because of the information I got, I started thinking about waste in a different way. I started changing my behavior. Somebody said, I used to drink water in plastic bottles every day and then throw them away, and just forget about them. But now after the project, I know those bottles go a few miles from home. They go to a landfill, they will stay there forever. So because of that, I stopped drinking water in plastic bottle. So the important thing is all this incredible amount of information we know today about our cities, about our behavior, about quantified self, is something that can help us to know more about the consequences of what we do, and hence, perhaps, change our behavior. There's a third thing we learned from this project, and that was more unexpected. It happened more recently, and it happened when a burglar came to our lab at MIT, and the poor guy stole a lot of things, including tags and computers that tell you where they go. And this is what happened. So, if we can put sensors on trash, we can really put sensors everywhere. It's about, everything being connected. even the most unexpected things. A very important thing is actually how sensors allow us to give us, again, information as people about different things. So in the next project, I'll show you what we did recently in China. As you know, air pollution is a big issue in China, and the traditional way to monitor air pollution in cities is by using, big monitoring stations. In a city such as Berlin, traditionally you would have a number of them, not that many, scattered through the city, and measuring air quality, and then sending this information to the government, to people supervising that, and that information then would trickle down and then be eventually disseminated if there were a problem of pollution or something that the population should know about. But again, today we can do things in a different way. Sensors are becoming much, much smaller. We can, each of us can almost become like a moving sensor or a probe. So what we decided to do, air quality is a big issue in China, and sometimes what we heard about last year is that big issue is just to get the data, to understand what is going on. In Beijing last year, the US Embassy was actually tweeting values of air pollution in order to share that with the population. It was difficult to understand at times exactly what the real situation was. So again, we said, what if we could actually give sensors to people? And we decided to focus on Hong Kong and Shenzhen. That's south of China. As you might know, Hong Kong and Shenzhen are almost the same metropolitan area. The two cities are very close, but they're separated by the mainland Chinese border. So we actually engaged people and developed little sensors that people could carry with themselves and monitor and measure air pollution and share it with others. And look at what happened with the results. What you see here, it's a video, and the color of the frames is actually proportional to the level of pollution. Red is higher pollution, green is lower. One country, two systems was actually the slogan of when Hong Kong went back to China. And here we call it one country, two lungs, because there's a big difference in air pollution between one side and the other side of the border. Now we are crossing the border. So this was actually to show you all the data we can collect from our cities, from the environment around ourselves, how the data can be used, how it can promote behavioral change. It's about sensing, as we said at the beginning, how we can sense our environment in new ways. I also want to add a caveat here. Sensing is great, can help us understand a lot of things about what is around ourselves. This is also a lot of data which is being saved and collected. And we all need to be very concerned about what happens to it, who has access. I wanted to show you this. This is actually by Italo Calvino. It's something, Italian writer Italo Calvino. It's something he wrote before the internet. Or certainly before the internet was really widely spread. He wrote this, imagining a world where everything would be saved, where everything in our physical world would have a digital copy that would be stored. He said, imagine an archive that will bring together and catalog everything that is known about every person, animal, and thing, by way of a general inventory not only of the present, but of the past too, of everything that has been since time began. In short, a general and simultaneous history of everything, or rather, a catalog of everything moment by moment. And that is indeed what we are working on, and we can feel satisfied that the project is well advanced. So imagine that, and a lot of this is what is happening today. Now, needless to say, if you read the short story by Calvino, that condition that he imagined leads in just a few pages to intrigue, drama, and ultimately murder. Now, that's fiction, but I think there's very big issues that are coming up from the fact that everything we're doing in our life, every moment of our life, is leaving digital traces that are stored in databases, and then who has access to the databases, how the data is controlled, and all of that is something we should all be very concerned about and talk. And I wanted just to mention that for the second time at MIT, we organized a forum called Engaging Data. At the last one, we had Noam Chomsky, a colleague and activist at MIT. We had Ed Snowden's lawyers. We had many others, because we think that's a discussion we should all have together. It's great to have data about cities. We should also look at data in a critical way, in a broader sense, about how we are digitizing everything in our life and in our society. But having said that, I wanted to go from the sensing side, so the collection of data, to the actuation. How that can help us to change and transform the things and the environment we live in. And I wanted to start with the first project I did when I arrived to MIT. I was working with Hiroshi Ishii at the Media Lab, and we did this. It was called Sanscape. It was like a table made of sand. You had a 3D scanner at the top. You would get in real time the surface of the sand. And then as you change this model, so as you create different shapes and landscapes on the sand, then the system would get in real time the topography of the sand and then send you back information that might be useful. Think about it as something that you could use for studying landscape, or really for creating like a 3D model that magically responds to you in real time. You change it, you change the model, the system knows it and sends you back information you might be interested in it. In this case, you simply see the height or the slope or the topography and so on. Now, at the time, that was around 10 years ago, we did this. We were very excited. We had fun. But we were imagining, what if tomorrow, actually, the sand could start to dance? What if we could have the same thing where actually every piece could be actuated as well? So our environment could become responsive also in terms of atoms, not only in terms of bits. And at the time we tried, but we didn't succeed. We didn't have Arduino at the time. Small motors were not small enough. But it was quite exciting to see last year that Hiroshi Ishii managed and unveiled a project that did exactly what we were thinking about at the beginning, about a sand that dances back and responds to us. There, but actually all the 3D information is captured, and then the system responds. So the environment responds to him in 3 dimensions. So, and this is really what we try to do, what we've been trying to do both at the lab and in the office over the past few years, to try to see how the environment around ourselves can actually respond to us in a more dynamic way. In this project, we actually used a projector that has in front of it a rotating mirror, similar to the ones you see in clubs. So it allows you to take light and throw it all around. And this projector from one position allows you to turn every surface into a living surface, into a projection surface. So when we designed this building, what we tried to do was an architecture that would be based and informed by that projection. We wanted something to look beautiful, but something where every surface could become then a living surface, a surface animated with digital information. So here you see actually the shape of it, the shape that, of course, was responding to the living habits and all the traditional parameters of architecture, but also to the idea that maximizing the co-visibility between that projector and all the surface around. And then the place can be turned off, so you see just a traditional architectural space, and then you turn it on, and every surface can become a living surface. In this other project, we looked at something else that we are quite concerned about, is about how much energy we waste in our buildings. And what we did in this paper, we looked at the MIT campus and looked at where the people are and where energy goes. And if you plot the curves, you see absolutely no correlation. We heat our buildings when there's nobody there. We cool our buildings when there's nobody there. Think about what happens in our homes, the places we live. During the winter, they're empty during the day, but still we heat them. And that's a lot of wasted energy. So we thought, what if we could think about a system where instead of heating space, we were throwing heat on people. We called it local warming. We did a test outside of MIT that was last winter, very cold. So people entering 77 Mass Ave, that's the main entrance at MIT, you see it here, would have a little bubble of heat following them. So you step on the carpet, and then this kind of bubble would move with you. You could also customize the bubble. You could say, I want to be at 20 degrees, or 24, or 15, or 16. From that, we developed an installation. It was at the Venice Biennale until a few weeks ago, where we imagined a ceiling that would actually do this to all the people underneath. Here is the making of it. So you see here, for the Venice Biennale, we want to make it quite visible as an installation, but you could imagine something seamless, something that's in the false ceiling of a building. It actually supplements the baseline heating you have with a little bubble of heat or cool that follows you. Again, I said of cool as well. This is something we had just a few weeks ago in Dubai. A big issue in Dubai, as you know, is that during the summer it's too hot. Public space, outdoor public space is empty or almost non-existent because of the heat. And so again, you can spray water to cool it, but instead of spraying water everywhere, you can create this little cloud that follows you so that, again, you save energy and you create an environment that responds to us in a dynamic way. We just opened last week a pavilion at the World Expo. These were the initial renderings, but there we have been experimenting with algae, how biology as well can help us make architecture more responsive, create a surface made of algae that, again, can shade us in a dynamic way, but also captures the energy of the sun that then can be reused. At the World Expo, we also had another idea. It wasn't fully implemented, but I still share it with you. And it's an idea with which we won the competition for the Pavilion for New Holland, one of the top agricultural equipment manufacturers in the world. And we started from the idea of self-driving. You might all be familiar with this. This is actually a car with self-driving capability. You see the two little ears that you see to the side. They are LiDAR. They scan the system. They scan in 3D the environment around the car, and they allow the car to navigate almost like a human, to drive like a human. Self-driving technology is there. We got self-driving cars all over the world being tested. As you know, Google has some, big car companies have some, universities, MIT have others. So we thought about what happens if tractors actually become self-driving. And the interesting thing is that when that happens, you can think about the way the tractors can move in a very precise way on the landscape and actually put seed and deploy seeds in a much finer way. So this is actually the board that we did for the competition, the board that won us the competition for the New Holland Pavilion. But we were inspired by the work of Benedict Gross, who was actually also at some point at our lab at MIT. And what Benedict did was did a test as part of his master thesis at RCA, where he used this in order to see how we can go from monoculture to something more complex. As you know, nature usually doesn't use monoculture. We have to use monoculture in traditional way of farming. But if you go self-driving, you can think about a system where tomorrow you can almost sprint the landscape. You can put seeds in different places, and you go beyond monoculture, which has many limits, as we all know. And this actually, I just wanted to share Benedict's work. Is what he did. He set up a system here in Germany in order really to try to seed and treat the farming almost as a way of printing the soil. And I want to share with you a couple of projects we are working on today. We work on this project for the Olympics in Rio. And here what we are doing is again, trying to create an architecture that responds in a dynamic way, but for obtaining something that's the opposite of a dynamic architecture. Is the idea that, if you can bring people in the water in a different way. In the brief we were given actually by Arfuturo, a main architectural foundation in Brazil, was can we do something to engage people with water? Water is a big issue in Brazil today. There's a big drought, especially in Sao Paulo and Rio. So the idea was, can we use digital technology to allow people almost to enter inside the water in a way you couldn't normally do? If you normally have a barge, you're up on the water, or you're inside, but basically you cannot be floating at the surface. And the reason is that to float on the surface, then you have an unstable system. You have a system where if you add more people, then the system will sink. And so what we are doing here, we're using technology similar to submarine technology in order to create a space that allows us to carve volumes out of water. As you see here, the surface, that's the surface of Lagoa in Rio de Janeiro. And it is that that flows dynamically, responding to the amount of people you have, in order, yes, to create an architecture which is based on subtraction instead of addition, and allowing people to be exactly at the level of the water, on the water line. The Pavilion is just a public space where you can go for a conference, for a meal, for for a cafe, where you can learn about water with the water lab, so it becomes like a public space for the city, and something that could help, teach people about this crucial issue, especially now in Brazil, during the Olympics. Water is also what we've been working on with the World Expo back in 2008 in the city of Zaragoza. Water was actually the theme of the expo that year, and the mayor came to us and said, is there any way we can use water in a different way today? And so one of the ideas that came up, water has been a beautiful ingredient of architecture and planning for hundreds or thousands of years, was imagine we could use it like this. Imagine you could have a pipe, like you see here, and that pipe has many tabs, opening and closing, controlled by a computer. Then you can create a living water wall, a wall that opens up when you approach it or where you can show text or images or patterns. The mayor liked the project, so we got the commission to design the building at the entrance of the expo, called it Digital Water Pavilion. All of the walls are controllable. You can show images, text, or patterns. No doors or windows. When you approach it, it opens up to let you in. And then when you're inside, also, all of the walls expand and shrink based on how many people you have. The roof is also covered with a thin layer of water. And then if you got too much wind, you can lower the roof to minimize splashing. Or at the end of the day, you can close the building and the whole architecture disappears. Hopefully without anybody underneath. We got sensors for that as well. Here you can see the building before the opening. I like this picture because this guy was there. You see he has a trolley, was going to the station, but stopped there and said, what the hell is happening here? Here it was actually digital projections on the top of the water. So it's digital and physical pixels being combined together. And this was myself trying not to get wet. And I should tell you now what happened one night when all of the sensors in the building stopped working. And, that night we were terrified. We were terrified because the building would keep on doing its own crazy things, like cuts and holes and other things, but without responding to people anymore. But actually, that night was one of the most fun nights ever. That night, thousands of kids from all of the city came to the building to play a new game. Not anymore a building that opens up when you approach it, but a building that you need to engage like this. And for us, it was an important lesson because as architects, engineers, we always think that we know how people will use the things we design. But then reality, and especially human reality, is always a surprise. I wanted to finish and start wrapping up with showing you one project in more detail, because we think that when architecture hybridizes, when architecture is mixing, as we see, with sensing, with digital technologies, with many other dimensions, then the process of design is changing as well. And I want to share it with you with one project from the beginning till the end to examine a bit more the methodology we developed both at the lab and at the office. The project is something that started a few years ago with the city of Copenhagen. The mayor came to us and said, is there anything we can do using ubiquitous computing to address traffic in Copenhagen? And the interesting thing is that traffic in Copenhagen means a lot of bicycles. Copenhagen is a city where between 30 to 50% of all trips every day actually happen by bicycle. So we started thinking about bicycles and we came up with the following idea.
Welcome to the Copenhagen Wheel, the wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it for when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience of the city. It connects you with things a cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
So that was the initial idea. Again, this started with a workshop at MIT, different ideas, including this kind of funny-looking wheel. But at the beginning, it was not much more than a funny-looking wheel. There was not much technology in it on how it could be developed. But again, if you got an idea and you're in doubt, if in doubt, let's try it out. That's the first sketches we did to say, well, how could it pack together batteries and the motor in the same wheel? This is the first prototype developed. The batteries, the motor, all assembled together. Today, as you know, it's very quick to do fast prototyping, rapid prototyping, use laser cutters and 3D printers in order to make a model. The first wheel didn't look very good, but actually was working. And here you can see it presented with the mayor of Copenhagen in the main square there. So the mayor liked it and said, OK, let's go ahead. So again, back to the drawing board, rethinking what this wheel really wanted to do, trying to clarify the brief to ourselves. A new sketch, all the different components, rethinking the inside. Here you had designers working together with planners and also with mechanical engineers and electrical engineers. Sorry about this. Picking the motor. Combining, putting all the pieces together, and all the pieces inside the hub in order to contain everything inside the wheel. And then we had to connect the hub to the rest, to the rim outside. This was the first test, quite ugly, as you can see. This was a better one, but actually it didn't work. And you can tell it doesn't work because there's not enough bracing from the center to the outside to transmit the torque to the outside of the wheel. And then we came up with this idea, which is the hub to be connected with spokes that simply connect the rim outside, touch the hub without being attached to it, but simply simply rotate on the hub 180 degrees and go back to the rim. And we liked it because it has something magic about not having spokes connected to the hub, but we didn't know if it would work. Again, if in doubt, let's try it out. Some people in the lab thought it would work. Some people thought it wouldn't work. Again, this is the first model, simply laser cutting or 3D printing the hub, connecting all the spokes. He was very skeptical, as you can tell. But actually, this became the way to do it, to spoke the wheel, and to connect it. And that's actually how the wheel works today. And then, of course, there was all the user interface. Here, graphic designers at the lab and interaction designers working together in order to control the wheel from the phone in a very simple way, just with an app. And finally, all the sensing component I mentioned before. Today people do sensing with bikes. Believe it or not, but this happens today. But I wanted to go down another route, something very small, to actually get data from the environment that could be meaningful for people. So there's a little sensor we put inside the bike to measure CO exposure, noise, NOx, distance, and so on. And look at this, just with a few bicycles in Copenhagen, very quickly you cover the whole city. Is what we saw before in Hong Kong and Shenzhen, how just a small number of sensors can actually give you a lot of information about the city if you share this information with your fellow citizens. And then, we had to build the prototypes the mayor wanted to show in Copenhagen at the big summit where President Obama and others were. So we had to build a number of them, combine everything together, program it, ship it there, and then finally present it. This was the first prototype over there. Here was the mayor of Copenhagen here. The little clip, next clip, you see the mayor of Copenhagen and the mayor of Toronto trying the first prototype build of the wheel.
felt it. Excellent. This bike is fantastic. It's incredible. It takes no effort. You see my bike? You start pedaling and the motor takes over. And then it will tell you the air quality, temperature. Incredible first. It's amazing to see an idea come to fruition like that.
Well, and to wrap up this, I want to share with you also how this then became a startup. It started a project at MIT, and then it became now a company. If you look on our website, you see since a week ago there's all the lines that are, all the pictures that have been taken in the factory on the production line in Detroit. We got a line in Detroit and one in Europe, and that's also how the project developed from an initial idea to first the prototypes, bringing people from different disciplines coming and collaborating together, and then some of this team really wanted to turn it into product and doing a startup, which is now manufacturing. What I'll show you now is the video of the product. You know, the product looks pretty much the same, but in the middle, you got years and years, if you add a full-time equivalent, you know, of people's work, if you combine it together, in order to turn the initial idea into the first prototype, into something that then can finally be manufactured.
This is the Copenhagen Wheel. It turns your ordinary bicycle into a smart electric hybrid by simply replacing your back wheel. Connect it to your smartphone, download the app, and you're ready to go. Bicycles are a great way to move around, yet sometimes distances are too long, hills can get in the way, and hard journeys to work may leave you covered in sweat. The Copenhagen Wheel is here to change all of that. The technology was developed over several years at MIT, together with the city of Copenhagen, one of the world's most innovative places for cycling. Its original inventors licensed the technology and founded Super Pedestrian, the startup where we are now working around the clock to bring the wheel to you. Like the best riding companion, the Copenhagen Wheel learns how you pedal and integrates seamlessly with your motion. It captures your energy when you brake or go downhill, and gives you a push when you need it, with 3 to 10 times your regular foot power. It's easy. Ride it just like a normal bike. As you pedal, the motor automatically kicks in, with no additional throttles or buttons. All technology for the Copenhagen Wheel is contained within the red casing, including motor, removable batteries, wireless connectivity, smart locking, multiple sensors, and an embedded control system. Use your smartphone to customize your ride, monitor your physical activity, gather information from your environment to share with your friends and fellow cyclists. And if you're a software developer, you can even create your own biking apps. So whether you carry yourself, your kids, or your gear, hills seem flat, distances shrink, and you can cycle just about anywhere. So transform your bike and transform the city. The Copenhagen Wheel.
And what I want to say is that all of this would not have been possible with today's ability to get funds online. It's not only about VC, venture capital, it's about all the early adopters who wrote and who got the wheel. So in a certain sense, the story here is not only how, if you want to look at this space in between digital and physical in the city, you need a collaboration between different disciplines, but also how today the tools of the network can also help you then to do things you couldn't do before in order to turn an idea into something concrete. And that's really what I wanted to finish with. We used to think that knowledge was something like this. We used to think that we could actually put everything that humans had ever done in the right spot. That was the idea of St. Thomas. When he wrote the Summa, he tried to put all of human knowledge and condense it into one book, beautifully and perfectly organized. Well, we know that that is not the case anymore. We know that if we need to think about something that might look like a map of human knowledge, it might look more like this. This is actually a map that was on the cover of Nature, one of the most respected scientific journals. And actually what they did here, they took 800,000 scientific papers and looked at the links between them. And what you see something where everything is connected with everything else. You see beautiful links between brain research, with computer science and mathematics and the social sciences. So something that's a web, which is almost like the web, the World Wide Web, the web we got on the internet. Nature also went to look at the most important papers in the past and the most important papers today. There's an easy way to measure the importance of a paper is about citations. How many people cite the paper? It's similar to the likes on Facebook. How many people like your post, and then you can measure the impact of the paper. Now, in the past, we used to have the most important paper used to be written by one author from one very well-defined discipline. Today, the most important papers are usually from many authors collaborating from different disciplines. And we think that something like this is finally also entering the space of design and architecture. You know, architecture in the past was what is encapsulated in this picture. This is actually Le Corbusier, one of the most well-known architects of the past century, presenting his plan was then for Paris in the 1920s. And his ideas for Paris were quite simple. Were basically demolish the whole city, just leave Notre Dame and a couple of other things as memories from the past, and replace everything with his modernist towers. And when you look at this picture, you see the hand of Le Corbusier, which is the hand of the architect, but almost like the hand of God, of one person single-handedly making decisions that will affect millions and millions of people. People even said, you know, we couldn't work collaboratively in architecture. A camel is a horse designed by a committee, is a saying that people used to say. You cannot really work collaboratively. Otherwise, you will not end up with a beautiful horse, you will end up with a camel. Well, again, we think all of that is changing. That's a book that's coming out actually this month with Thames and Hudson. It's called Open Source Architecture. We try to see how open source can also affect a lot the space of design, the space of thinking about our cities and our buildings. You know, that book came out of a little project. It was an editorial a few years ago that I wrote for Domus, a design magazine, Italian design magazine. So Domus had an issue on open source architecture, and he asked me to write the introductory op-ed. And I said, sure, I'm happy to do it, but if this is about an issue about open source architecture, why don't we do the op-ed itself in an open way? Why don't we do it on Wikipedia? We write it together. So this is what we did together with a number of people initially. Initially, we had Nicolas Negroponte, Hans-Ulrich Obrist, Paolo Antonelli, Dan Hill, many others actually collaborating in order to do the first text. And then the text then on Wikipedia kept on evolving. If you go on it, if you go on the open source architecture page on Wikipedia, you will see all the transformation and how people keep on adding to it and how open source can really benefit and can really enter the space of design. You know, when I did that, when I did the op-ed, then there was an issue. The issue was that Domus usually wants to have a picture of the person who does the op-ed. And which picture should we use? Well, we couldn't use the picture with all of us. There simply wasn't enough space. And I didn't want to put my picture. You know, I was just one person among many having contributed to do this. So in the end, we gave Domus this picture as the author. So the picture of all of us combined just in Photoshop, one on the top of the other. And I wanted to finish with this because my wish, the wish I would like to share with you, is that tomorrow's architect, tomorrow's designers will look a bit less like Le Corbusier, the person who single-handedly can plan and propose to demolish all of Paris and make plans himself affecting millions and millions of lives, millions and millions of people, and a little bit more like this, an architect or designers that belongs and is part of all of us. Thank you. And as part of the kind of the open approach and open source, as we said before, I kept the presentation a bit shorter, so it would be great, if there's any comments or questions or ideas or challenges that, yes, I see a hand.
The microphone, oh yeah, it's working right now.
Thank you so much for your presentation. I would like to know, how are you dealing with all the privacy implications in all these projects that are collecting so personal data from so many people?
Sorry, I didn't understand you very well. There's a bit of echo here.
How are you dealing with the privacy implications?
Privacy, I think, that's great. That's why I put this slide about Calvino. Now, think about this room. think about this room probably 10 or 15 years ago. Well, in this room 15 years ago, you would have had probably a couple of cameras. People would have taken a few pictures, a little bit of footage. And those pictures would have been printed, would end up in a drawer. After 10, 20, 40 years, they would have been just thrown away. So nobody ever thought that taking picture, for instance, was an issue in terms of privacy. Now, fast forward to today. In this room, there's certainly more cameras than people. All of your phones have at least 2. Every computer here has some. People are tweeting, are taking pictures, taking footage. And so even something as innocent as taking pictures can become an issue. I believe it was Switzerland or Austria, one of the first countries to ban Google Street View, really for these reasons. Taking footage, that pervasive footage can become an issue and a threat to privacy. So what I'm saying here is that this is something that's much more profound than just what is happening in cities. It's something which is every moment of our lives is being, as I was saying before during the presentation, is being stored, is being recorded, leaves digital traces. And all of this is in different databases today. But if you were able to combine those databases digitally, you could really reconstruct probably every 5 minutes of our life today, probably every minute, every time your phone sends a text message, downloads an email, or does something else. That's like a digital footprint that you're leaving. Now, what should we do then? I think it's a very important thing. It's something that's really changing our relationship with the world, with what we can forget. It's going to be very difficult to forget in this new condition. That's why I use the Calvino example, because some of the things that he uses in fiction are actually very profound concepts that we are facing and dealing with today. So what should we do? I think people are discussing many options. There's technical solutions. You could think about systems where you're tracking information with other information. So you're using data in order to follow data and see when data is leaked. You can think about a transparent society. Apparently, some anthropologists think that when we were living, a few thousand years ago, all of us, when we were living as hunters and gatherers, at the time, supposedly there was no privacy. So everything was known to everybody else. We could think about a society where that is also the case. Certainly it would be better to have access for everybody than a system and a situation like we are seeing today, where some people are having more access to the data than other people. There's an asymmetry. Big corporations and certain states have more access than others. So anyway, there's many things on the table that we could discuss. I don't think we should discuss this today. I don't think I should. I got some ideas, but I don't think I would like to share my ideas. What I want to say is that it's very important that we're all part of that conversation. That's why we've organized for the second time the Engaging Data Forum at MIT, but we should all be part of that, because the way our society will be tomorrow depends on the choices we do in this space today.
Do we have one more question, perhaps? Just raise your hand and I come along, even on this side. No.
I see one down there, or no? Where? No, maybe it was
no.
Somebody scratching their head.
Okay, so thank you very much for this.
Thank you.
Thank you. Carlo Ratti.